Right, so I'm Clint Goodman, and we'll be talking about how to make large refactors with JSCodeShift, and this is me teaching my 2- and 3-year-old how to do the same thing. So if they can do it, you guys can do it too. All right, we have a lot to cover, so I'm going to try to not to be rushed, but very efficient. There's a lot of information here. So first, why would we ever want to make a code mod? I can think of at least 2 examples that I've done in the past couple years. One is if you have code that is spread throughout tons of repositories, lots of lines. I have here an example that I'm going to show at Adobe where we have a library called Phoenix, which really stinks, and we need to move off of it to Adobe Spectrum, which really rocks. And I mean, it covers hundreds of repositories and thousands of files. And so we could try to manually move everyone off of this library, but that would be impossible. We really do need a code mod to make that more automatic. I kind of already just explained this. So I work for Workfront. I've been working there for 7 years. We just recently got bought by Adobe, which, by the way, Adobe is hiring. There's 14 developer positions open just here in Lehigh, and it's an awesome company, my favorite company. Really like it here. But like I said, we have Phoenix here, which is our own system, our own component library written in React, and we want to move to Adobe Spectrum. And that was the slide I showed before where it's just spread everywhere. And so we really do need a JSCodeShift or a code mod to be able to write and to convert to that. Another reason why you might want to write a code mod, maybe in this example I have here, I actually just want to write a code mod to change one single file. But in this file, it was one huge file that returned a bunch of different components, and I wanted to extract each component into their own file, do some prop matching, create a unit test for each of those, and I was really worried that I was going to mess it up and have a copy and paste error. And so I wrote a code mod just for one file so that I didn't have to worry about it. I could programmatically refactor my code without me having to do anything manually and introduce the risk of human error. So that may be another reason why you want to write a code mod. Okay, so I keep using the word code mod. Let's talk about what a code mod is. And before I even explain what a code mod is, I'm first going to explain what an abstract syntax tree is. So internet's not working for me here, so I'm going to pull up this video for you guys automatically, and we'll watch it here.
Interviewer, what is an abstract syntax tree? You. When we write code, we want to use text that is as concise as possible, but things like compilers want a lot more information to fully understand your code. So first, we perform lexical analysis to tokenize all the different parts of the code, like variables, operators, functions, and so on. It's like finding all the nouns and verbs in a sentence. We then take that list of tokens and parse it into a tree that represents the structure of the code. This abstract syntax tree can then be safely used by compilers to generate a different type of code, like turn TypeScript code into JavaScript or C++ into machine code.
Okay, cool. So abstract syntax trees, also known as ASTs, are super awesome. So I'm going to show you what they look like. So I have here source code on the left, and I'll make this bigger. And this is using the example I brought up earlier where we have my Phoenix package, which we want to get away from. But first, I'll just show you how an AST looks like. So here's the source code on the left, and here on the right hand is a tree representation of that code. So my source code really is composed of just 2 things. One's an import declaration, and the other one is a function. This function has a name. It's called example. The function also has a body. The body just has one thing in it, which is a return statement. The return statement returns JSX. JSX is composed of opening and closing tags with children in between. The opening tag has a name, and it's called button, and it has attributes, and one of those attributes is a arrow function, and you can just kind of see how this here on the right is showing a tree representation of the tokenized tokens here of the source code on the left. And this tool, ASTExplorer.net, is also super cool because I can hover over things here on the right, and it shows me what it correlates to on the left, and vice versa. I can click here on the left, and it'll jump me straight to the tree on the right. And so once we have an AST, a tree representation of our code, we can then walk through that tree. Let me show you an example of how you might do this using TypeScript. So one of TypeScript's functions is really just a glorified AST parser and transformer. So I'm pulling in here the TypeScript library, and I'm going to create an AST by passing it in raw text in just this big string. It's the same text you were just looking at. And I'm also going to tell it that it, this contains TSX and things like that. And then after this, I have an AST. So I can use TypeScript to say, hey, for each child here at the top level, find all of my, is this node that I'm looking at, is it an import declaration? If so, and if its name is Phoenix Solid, go ahead and push it up to my array here and return that. So like this is an example of how to programmatically walk through an AST. This one is recursive, so get identifiers. I'm going to call it, and I'm going to walk, which is this function, and then I'm going to recursively for each child, I'm also going to call walk. So this is going to go through the whole tree, looking for identifiers that are either button or add toast, and collect all of those. So you could write a lot of things using the TypeScript library. It is a little bit tedious, and this takes a little bit of work, and so just note that. But if you wanted to learn more about how to do this by hand, you can. There is a codeshiftcommunity.com website that I really like. This is a website dedicated to codemods. They've put all their eggs in the basket for JSCodeShift. Has the best library around, which I agree with right now for JavaScript it is. And it'll show you how to use their library, which is a lot easier to traverse than this tedious like visitor pattern that TypeScript has. All right. If it seems like I'm going fast, it's because the coolest part is at the end. So, so how do abstract syntax trees fit into our process of making code mod is that if we can take source code, make a tree representation of it, then I can programmatically change that tree a lot easier than I could with the source code and using regular expressions in some sort of crazy find and replace. With this tree, I can say, hey, move this leaf here, or create another leaf, or rearrange things, and I can do this a lot easier in a tree format. And then I need something to take that tree, put it back into source, well, I guess destination code is really what I should call this now, and it'll be JavaScript again. And that's how a code mod works. And that's also how TypeScript and Babel and all those different tools work too. So let's talk about those tools. There are a lot of tools for ASTs. Whoops. That text doesn't look very good, but here's at least a few tools. Acorn is a very, very popular AST walker. Babel, all of us are probably using it. It's an AST tool. ESPrima is pretty old. Flow was just a big mistake to begin with. Recast, I put in yellow because it's the only one on here that's not a parser. It is a refactor tool, and it can use any parser that you pass to it. And recast is pretty cool. And of course, TypeScript, we all know, supports types. So these are some of the low-level tools. I'll just give you an idea about how popular they are. Acorn has 72 million downloads a week. And I discovered, I think this is not because people are manually downloading Acorn. You guys have probably never heard of it. And so it's really not that popular. It is just a sub-dependency of a lot of tools like ESLint, Prettier, Terser, Webpack, and those types of things. So that's why that downloads are so high. But you can see something like JSCodeShift, which I'm about to promote, has 4 million weekly downloads a week, and and this is not a common sub-dependency of something else. So this is 4 million people, or 4 million downloads are happening per week. This is a very popular tool, unlike Putout, which claims to be its competitor, and it's not. I'm just going to simplify everything for you. If you're wondering, which tools to use, because if I come back here to this tab, there are a lot of different parsers here, and there's a lot of different transformers. And so when I began, I'm just like, holy cow, which one am I supposed to use? And I'll just make it very simple for you. Use JSCodeShift for just about everything, and for your parser, I would use TypeScript because it supports types and JavaScript, and it supports all the modern language features. So TypeScript pretty much rocks. And JSCodeShift does too. So let's talk a little bit more about JSCodeShift. So JSCodeShift was made by Facebook, and it was written almost entirely by one person who's now left Facebook. So it is somewhat community maintained now. Not a lot of new features coming out, but that's okay. It is actively maintained. But it does provide 3 things that are very important. So if you make a code mod, that's cool, but you need to be able to have some sort of CLI to make that code mod run against hundreds or thousands of files? Well, JSCodeShift provides a runner for you to do that. The second thing is, as you can see from my TypeScript example, if you had to write all code mods like that, you would hate your job, right? And JSCodeShift has a really nice library, much more functional and more familiar. It's like working with arrays. It's very nice. And then the last thing, which to me is maybe the most important, is that JSCodeShift comes with unit testing right out of the box. So you don't have to wonder if your code mod is working. You just know because you're running code mods. Okay, so I've talked a lot, and I've talked really fast, and I'm sorry about that. But writing a code mod is difficult. And here's one of the reasons why I think it is because, let's say I want to write a code mod, so I learn all about ASTs, I learn about JSCodeShift, and I'm really good at it for a few days, and I finally write my code mod, execute it, and then several months or years will pass before I need to do it again. And then I need to relearn everything all over again, and it's like I'm learning it for the first time. And so writing a code mod is very difficult to do because most of us are not a full-time code mod writers, right? We just do this every once in a while, or you need to make a ESLint rule, or you need to make a Babel plugin or something. Not very often do you need to do that. So the alternative is you can manually change your code, but as we saw, that could sometimes be a lot worse. So what do we do here with the difficulty of how to make a code mod? And I'm going to give you the secret, which won't be a surprise to you because it's 2023 and there's really nothing else on the news right now. It is ChatGPT. ChatGPT can write code mods for you, and I'm going to take the rest of the time to demo that for you. So I'm going to use the example where I had a component library called Phoenix. I want to go to a component library called Spectrum. Okay, so I came up with a prompt that looked like this. Hey, ChatGPT, you're a code assistant. I need to write a code mod. I'm going to give you 3 examples of what the code looks like now. And then I'm going to give you 3 examples of what I want the code to look like after a code mod. And I want you to write the code mod that goes in between. I didn't know if ChatGPT could do this. And just to show you that I'm not lying, that I did it myself. I really did ask ChatGPT exactly like this, except for I gave it 3 examples, which I'll go over here in a second. And then it spit out a code. But first, before I show you the code, I just want you to appreciate what ChatGPT is having to do by looking through the examples that I gave. So one of the components of our component library is a toast, which if you don't know what a toast is, it's kind of like this little snack up here at the top. And so we have toast in Phoenix, and our toast accepts 2 arguments, the type of toast and the body of the toast. But in Spectrum, it just accepts the body of the toast, and you specify what kind of toast it is by a property of toast Q. So I gave it this before and after example, and I'm curious to see if it can figure out the rules to make this code mod happen. I gave it 3 examples, so this is the second example. This is with an error toast, which Spectrum calls a negative toast. So, and I kind of made the function a little bit different to give it some variety to learn from. And then this one isn't using React at all. I gave it both a success and an error toast, and I want it to spit out a Spectrum positive and negative toasts. And as I showed you, it spit out this code, which even had comments and everything to explain it. So I don't have to be an expert about writing code mods to be able to understand what ChatGPT is doing here. So I've copied the code here, and let's just walk through it really quick so you can check it out. So right now, it looks like it is using JSCodeShift to look for all import declarations that are coming from Phoenix, and it's going to replace those with coming from Spectrum instead. Then it's going to go through and find all call expressions. Call expressions are like when you call a function. It's going to find all call expressions called add toast, and it's going to look and see, hey, what are the arguments that were being passed to add toast? It looks like there's 2 of them, the severity or the type of toast. And then the message or the body of the toast. Like these are the variables names that ChatGPT picked, which I'm fine with. And we're going to do some mapping here to what it should be in Spectrum. And then I'm going to create a new call expression from scratch off of toast Q, pass it the same stuff. I'm going to replace all of these add toast function calls with this new one. And then I'm going to apply the transform and turn it back into source code. So this is great if it works. So let's see if it works. Like I said, JSCodeShift comes with unit testing built in. And the way you do that is, or at least one of the ways you can do that, is you provide an input and you say, after the code mod, I expect it to look like this output. And the unit test will run the code mod and make sure that it does match, which was really convenient because I gave this exact same input and the exact same output to ChatGPT. So really, you can look at ChatGPT as just trying to to write the code behind my unit test for me. And so let me run yarn test. Let me make sure I have it set up correctly. Oops, I meant this file. Okay, yep, we're only running toast test right now. And let's see what it's got. So, okay, big bummer. It didn't do it right. It messed up on the imports. Instead of keeping the one import that should have been kept, it combined them both into both, or it consolidated into one import. So, dang it, it didn't do it right. But look, it did get the rest of the function right, which was actually the harder part to begin with. And so, there's no diffs here. So again, it did most of the code mod right. It just messed up on the imports. This is for example 1. Example 2 looks like the same thing. Couldn't get that import thing figured out for some reason, but it could get the function figured out. And example number 3, same thing. So on the imports, it totally botched it, right? So I'm like, well, I have 2 options. One is I'm a developer. I'm glad that I didn't have to write this code from scratch, but I can sure modify code that's already there and figure out how to fix ChatGPT's problem. Or I can just tell ChatGPT, hey, what you did was wrong on the imports. It didn't work. Here's what it should have done. And it says, oh, whoops, sorry about that. Let me fix that for you. And it's now going to do all this cool logic to say, hey, if there's just one named import coming from there, then replace it. If there was 2, keep the one, move the other one, insert it after. And ChatGPT totally knew what I was talking about and could fix it for me. So I think it's pretty cool that the first initial guess that I had at a prompt, I didn't even think too much about this prompt, right? I didn't do a lot of fancy prompt engineering or anything. I just asked ChatGPT my first guess. It came up with a pretty darn good solution on this very first guess, too. And that, to me, is really impressive. I did try other models as well. So ChatGPT, the one that I tried is this free one that all of us can access for free. I tried the paid version of ChatGPT, which is ChatGPT 4. The code is different. It's pretending to be smarter, I guess. It's okay. I used Claude AI. It was pretty primitive. I wouldn't recommend it. I tried Llama 2 Code Chat, the new hotness. It failed miserably. And that was because I actually think Llama 2 is probably one of the best things ever, but it clearly has no idea what JSCodeShift is. So it created a library, hallucinated a library, tried to implement it, and did just a terrible, terrible job. Which is also funny because Llama 2 is made by Facebook, and so is JSCodeShift. But anyway, I also tried Google Bard, and it was mediocre as well. So the free version, Chat 3.5, really did a pretty good job. But that was just on one example. And I'll show you how they compare, except for I left out Bard accidentally. And the free version did the best. That's pretty cool. So let's look at a different prompt. I have the same skeleton structure, but this time it's going to be for dialogues, okay? So I'm going to show you the before and after, and this one gets a little bit more complex. So here's the Phoenix dialog. It's called confirm dialog, and we need it to be an alert dialog from Spectrum. This one has a Boolean prop called warning, but we need that to now be a string prop to variant. Width is the same, but every other prop is named something different. And this at the end is going to be difficult for it to figure out. I have an object here to pass to the confirm button, and over here you can't do that, but you can pass a single Boolean prop, and we'll see how ChatGPT handles that. So this is my first example. I sent it. Second example, nothing too exciting here except for I didn't specify what type of dialogue, and in Spectrum you always have to. So I hope that it throws in the variant equals info there. And then the third example, again, nothing too special. I was just giving it 3 things to learn from. All the props are named something different. And hopefully ChatGPT does an okay job doing this. So let's look at the code that ChatGPT spit out. All right. So this is the 3.5 version. Again, we're looking for Phoenix, replacing it with Spectrum. And then we're looking for all of those confirmed dialogues, and we're going to make a new JSX expression here. And this is kind of interesting. This is not how I would have approached the problem, but actually I kind of appreciate that ChatGPT did it. Over here on the left are all the Phoenix versions of these props. And over here on the right is all the Spectrum version of these props. And the interesting thing is, like, it works because this was a Boolean prop, but now we can make it a string prop here. I don't know, kind of an interesting idea. Like I said, I wouldn't have done it this way, but ChatGPT did. And it goes through and replaces them and comments it all out for me. It's only cool if it actually works. And so let me now change this from running my toasts to now it will skip those and run my dialogue tests. Okay, so I have all the same dialogue input and outputs, and let's see how she did. So, dang it, didn't get it right again. It just cannot get those imports right. Not sure why. And as I kind of suspected, that last prop where it was an object and trying to make it into a Boolean, it didn't figure that out very well. But the rest of the transform happened right, so that's nice. That's happy. On this one, again, imports got messed up and it didn't throw in that default prop, but it got everything else right. Same story for the third example. So we're close. But again, I can just use ChatGPT again to say, hey, it didn't work. Here's what it produced. And ChatGPT will fix it for me. And on this one, I will say that ChatGPT 3.5 was pretty darn good, but ChatGPT 4 was a little bit better because of the way it tried to handle that 1/3 tricky prop case where it was an object and it's trying to make it into a Boolean prop. The reason why I have it commented out is that it doesn't compile. There's just one mistake in it. I just wanted to copy and paste like the first thing ChatGPT gave me, so I wasn't lying. But I would have used ChatGPT 4's output and just tweaked it a little bit. Everybody else did a terrible job, especially poor Llama 2 code chat. Just has no clue what's going on in the world. How do they compare? ChatGPT 4 was the best, except for one of the examples just caused a runtime error. I said compiled earlier, sorry. It has a runtime error, but some of these other ones did okay. And you know, if I'm poor, which I am, I'm just gonna use the free version and it does pretty good for me, right? And this is all JavaScript, so I'm not worried about sending in proprietary data to ChatGPT. They could have figured this out if they looked at my source code anyway with source maps. So I went a lot faster than I meant to. I probably spoke way too fast. But let me summarize this here at the end. So writing JSCodeShift or writing code mods is hard. It is not an easy task. But JSCodeShift is the best tool we've got, and I appreciate it. But I also think it's a temporary tool, which I'll talk about in a second. ChatGPT can write code mods for you. Not like next year, it can do it now. And that's pretty awesome. You may need to tweak some things that it spits out, and you may need to follow up with some follow-up prompts, but ChatGPT can get you most of the way there. And I think the future is very close for this being, like I said, a temporary problem. We're just like days or months away. Who knows? However, I subscribe to AI emails and like things change per day. Right? By the end of this week, we could have a tool that just writes code mods perfectly across your whole organization, and it just learns it and is so smart. You don't even have to spell out the rules; it just does everything for you. And in this past week, I pasted an entire JavaScript file into ChatGPT 3.5, and it spit out Python code perfectly. And I appreciate that. I didn't have to figure out how to do that because Python stinks. Sorry. So what I guess I'm trying to say is I wouldn't spend a lot of time trying to figure out how to master the JSCodeShift library or any other library because I don't think it's worth the time. I think AI tools are going to supplement that. They know the libraries and they're going to be able to do it for us. So rather than trying to become a master at JSCodeShift, I would work on learning these AI tools, learning how to do prompts to ChatGPT 5, learning how to use GitHub Copilot, which is so cool. And putting your time into learning AI tools because that's the future. And it's not even like the future, it's like now, right? This is happening now, I'm using it right now. And by the end of this week, it's gonna be an entirely better game because every week AI gets better. And so that is my talk about managing large scale refactors with AI. Thanks.